Hello everyone, welcome to my video. So in today's video, I'm going to continue the topic of designing a vacuum tube configuration file to be used with etracer software. And today we are going to focus on the configuration file for testing a pentode. Mark Walker of Blue Glow suggests me to use tubes like W350 or 6AU6 as an example. So I'm going to use 6AU6 as an example. So in today's video, we are going to design the two configuration files for 6AU6. One is testing 6AU6 under child mode, and the other one is a configuration file for testing 6AUC under pentode mode. So now we will begin with the configuration file for a child connection. So in the PCB menu, you can find in figure 18 the wiring diagram for testing a pentode. Here in this diagram, 6L6 is used as an example. So for pentode, assuming it's a indirectly heated pentode, we connect the heater supply to the filament of the two legs of the filament of the device under test, and we need to connect the cassette to ground. And for the control grid one, we connect it to the negative voltage supply, neg V. The second grid, the screen electrode, we use HV2 to supply voltage on the screen electrode. The third control grid, the suppressor electrode, in 6L6 is internally connected to the cassette, so we don't have to do the wiring for this electrode. But for some tubes, the suppressor grid has to be connected to cassette on the socket. So we're going to see that in 6AU6. And for the plate electrode, as we already know, now we use HV1 to supply voltage on the plate electrode. So basically, this is how we're going to supply the information we're going to supply in the wiring section of the software. Okay, so this is the software. It's the all parameters are reset. So now we can consult the data sheet of the 6AU6. And this data sheet is from GE, the General Electric. So in the 6AU6 is a miniature pentode, and the heater is 3 and 4. Cassette 7, control grid 1. The screen is pin 6, and the suppressor is pin 2. Oh, sorry, screen. Suppressor. So pin 5 must be plate. Let's look at it for sure. Suppressor, pin 5 plate. Okay, so then we need to select the connection for each pin. Again, this is only for the user. Suppressor has to be connected to the cassette, which is ground. Heater 1, heater 2, plate connect to HV1 screen connects to HV2, cassette connect to ground. So this this complete the wiring instruction, and we can type in the some information about this tube here. So it says miniature sharp cutoff pentode. So miniature sharp cut off pentode, and we can probably say, you know, the settings comes from GE blah 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 menu, something like that. Okay, and when we are ready, we can save the configuration, the temporary file anytime we want. And so 6AUC. Okay, so here I need to mention about the naming rule for me. If the device under test is not reservoir or child. So for example, for 6AUC it's a pentode, and so we are working on a child connection for this tube. So I'm going to use _child to indicate that the file is designed for to test 6AU6 under child connection. And I'm going to show you the naming rule I use for pentode connection. So now we can save it. Okay, so now we are ready to design the test configurations for each tab, and the plotting, and the configuration for the plot. Before that, we need to set up the filament voltage. So for 6AU6, it's the heater voltage is 6.3 volt with a heater current of 0.3 amp. 6.3 save. Okay, now I always start with full scan because that will give me an idea of the range of the voltage. So for full scan, we can check the maximum rating of the 6AU6 first. So the maximum rating for pentode connection is 330. So if we want to strictly follow the data sheet, we shouldn't supply the play voltage to higher than that. But when we look at the test curve provided, the curves go up to 400 volt. So or even higher. Here it's almost 420 volt. So we have to make a decision here. Well, what voltage we are going to supply, the highest voltage we are going to supply. And if for pentode, the plot even go higher, go up to 500 volt. So here I think testing up to 450 volt is adequate. So we're going to supply voltage on HV1 from 0 to 450 volt, and the maximum current here is 35 milliamp. And as I said, we should also check the power rating for this tube. So the power rating for this tube on the plate is 3.5 volt, 3.5 watts, 3.5. And we can cheat a little. So here we can see the if we display up to 450, and we display a maximum current up to 35 milliamp. This is where the power dissipation curve will be situated. It looks reasonable. You can probably make it bring it a little higher too. So if we have a full scale of 25 milliamp, it's also good. So I'm not sure. Let's use So when you design this configuration file, for me, because I don't have a 6AU6, so I have no way to test it. So if you find the supplied, if you find the supplied configuration file doesn't give you a nice look, you can always change the display range here by yourself, tweak it a little. Let's check 35 again. 25 looks better to my eyes, so I'm going to use 25 as a maximum current setting. Why we want to do that instead of following the curves in the data sheet is simply because we are not going to use we are not going to operate this tube above the maximum power dissipation. So in other words, we are not interested in the behavior of this curve above the maximum above this line. So it's totally okay for us to to keep the scale properly, so that the curves will will utilize a large portion of the plot. Okay, so HV1 is enabled. We want to start from 0 to all the way to 450, and for this one we want approximately 20 steps in the range. So 25 is a good choice. The maximum current, like I said, we don't use it in the I don't use it in the software, so we can set to 50 or something. Something makes sense to complete the configuration file. And for HV2, because now HV2 is used to control the screen volt. It's not a sweep source. It doesn't link to HV1, so we need to space. Sorry, it's a channel connection, so it's not a sweep source, but it has to link to HV1, and the linkage is 100%. So the voltage on HV2 will be identical to the voltage on HV1. Negative voltage, turn it on. It's a sweep source. And let's check the data sheet again. So data sheet, the grid voltage is from 0 to -12 with a step of 1 volt. Okay. So if you want the more curves here, you can maybe we should scan up to -14, I think. So 0 to -14. With a step 1 volt. Okay, so that completes the setting for scan, and also the plot settings area, so we can save the tip configuration again. So now we are ready to move on to the quick scan setting. So like I said, the quick scan setting, we should consult the datasheet for recommended operating point. And in GE's datasheet for China connection, it only supplies one operating point, so I'm going to use this one. So the operating point is a plate voltage of 250 volt. And if you look at the datasheet, it doesn't specify the grid voltage. Instead, it specifies the cassette bias resistor, which means that the test condition here is specified as a self-biased connection. So we need to derive the grid voltage from the cassette bias resistor and the plate current. Okay, so we have 330 ohms resistor, and the current across it is 12.2, so it gives us 4 volt on the cassette, which is equivalent to a minus 4 volt on the grid if the cassette is connected to ground. So to minus 4 volt. Okay. And the plate is not is 250, but we have to know, because the ways is the figures are specified. So now the cassette, because of the cassette resistor, the voltage on the cassette is not 0 volt. Sorry, the voltage difference between the plate and the cassette is no longer 250 volt. It's actually 250 volt minus 4 volts. So we need to take that into account. So we have to take 4 out of 250. So the plate voltage to cassette, because cassette in our connection is grounded, but in the data sheet the cassette is actually 4 volts above ground. Okay, so we need to take that into account and make the change accordingly. And for quick scan, we need to again, it's a triad connection, so we turn on HV2 and make HV2 link to HV1. Negative V is a sweep source, minus volt, and the swing, the recommended swing range is still 5% to 10%, and it's triad. We are interested in all 3 parameters. So now we have to fill in the reference values for this operating point. The collection current is 12.2. Transconductance 4800, and the amplification factor of 36. Okay, so in the data sheet, the plate resistance is not given. So we need to derive the plate resistance, and the way to derive the plate resistance is by the fact that mu equals to Gm multiplied by Rp. So if we divide mu by Gm, we'll get Rp. Mu here is 36 divided by 4800 and multiplied by 10 to 6, because the mutual conductance is given in micro. Anyway, so it's a 7.5 K for the plate resistance. Okay, so that's complete the setting for the quick scan tab. Save the configuration again. So we can now move on to the corner settings for corner test, and we are interested in we are going to use 2 test cases, one for the cutoff current and one for the current limit at the highest plate voltage. Okay, let's come back to the data sheet. We can probably pick the -12 curve, and because we have to take the maximum allowed plate voltage into account. So somewhere here, okay, and for me I'll pick -12 at 320, and the current shouldn't be above 1 milliamp. That will be my criteria. Let me put it down. 320. Remember, it's a triad connection, so HV1 and HV2 has to be has to have the same value. The negative volt is 12 volt, and the major current has to be smaller than 1 milliamp. And here is comes to a question about the setting up on HV2, the reading on HV2. So there's a couple options we can use. One is we don't test the current on HV2, or if we want, we can check because it's a triad connection, and from the measurement for triad, we notice that there is a scale factor between the plate current and the screen current. So let me show you the a measurement of a triad connected pentode. Okay, so this is a child connected 6L6. So you can see the screen current is scaled version of the plate current. So what I usually do is I check the data sheet and find the relationship between the power dissipation of the screen and the plate. So here the maximum dissipation for plate is 3.5 watt, and on the screen it's 0.75. So we divide it 0.75 divided by 3.5, you get a scale, it's 1 to 5, so it's a scale vector of 5. So which means the current on the screen lecture is probably of 1/5 of the current on the plate. So we can use that and dial in the test criteria. Put not this one. So let's download the 6AU6. Here 6AU6 chart. No, okay. So okay, I need to fill that in again. 320 minus 12, because I didn't save it. Okay, so we can use the scale version of it. So 0.2 MA on the for HV2, the current criteria for HV2. So for the second criteria, we want to supply the highest voltage on the plate, allowable for according to the data sheet, which is 330. So we can probably supply I don't know, 350, and we can check the current on -10. So the current is like 2.5 milliamp. So we can set the criteria, say at the test voltage of 350 volt, with a grid voltage of -10. The current has to be less than 5, and 1 milliamp on HV2. So that completes the setting for the two corner test cases. Okay, I need to come back to the full scan. I forgot to mention, because this is the we use HV2 here, so we can show the screen current on using the right y-axis. So we can turn on the right axis, and I make the maximum current the same as the left axis. So that's that way we can compare the plate current versus the screen current directly. So that completes the setting configuration files for 6AU6 under child connection. So now we can move on to make the connection for make the configuration file for 6AU6 under pentode connection. So we can save this configuration again under different names. So we can start with working on the file we used. So for pentode connection, I use pentode. And for pentode connection, we need to specify the screen voltage. So what I use is I underscore screen and specify the voltage on the screen electrode. So which screen voltage to use is totally up to the user. And the reason I only supply the child connected pentode in my configuration file is simply because there's so many, virtually unlimited power possible configuration for a pentode connection. It just changed the screen voltage. The result will be different. So in GE's data sheet for the typical operation point for pentode has two different settings. One with a screen voltage of 100 volt, one with 125 volt, and one with 150 volt. So let's use this column 150. So in the main, I'll give it 150 volt. Okay, so so the naming is very clear. This 6AU6 is connected under pentode connection with a screen voltage of 150 volt. Save. The wiring section is the same. Okay, because we just supply the screen voltage using HV2, and for full scan, now we want to check the graph again. So we want to look at the graph with screen voltage of 150 volt, which is this one. In this plot, it tests up to 500, but you remember in the maximum setting, only the maximum allowed voltage is only 330. So we can make a decision whether or not we want to test up to this high voltage, or we can stop at something like 450. So I'm going to start at 450, I think, and the maximum current here only goes up to 20 milliamp. So maybe we can use that to have a different test. Where's the plot? Okay. Oh, sorry. 20. Okay. So the display range is 0 to 450 volt, and the current is 20 milliamp maximum on both axes. Actually, I prefer 25. Okay, we're going to use 25, which is the same as the setting for child. Okay. The green voltage is start from 0 to -5. At -5, the current is very low, so and the step is -0.5 volt. So we're going to use that. 0 to -5 with a step of 0.5 volt. And this is a pentode connection. So for HV1. The HV1 setting is the same. We start from 0 volt all the way to 450 with a step of 25. On HV2, it no longer linked to HV1. It's not a sweep source, and we set a fixed voltage 150 volt on the screen electrode. Okay, and the heater is already set up in previous configuration file, so we just use it. Save it. Okay, so for the first scan tab is probably configured, and okay, so actually it's also specified the power rating on the screen electrode. 0.75. I don't use that in the software, but you can put that there for completeness of the configuration file. Okay, now we are ready to work on the quick scan tab. So again, we want to check the recommended operating point for the. We need to pick a correction point from the recommended operating points. Okay, in the data sheet there are 3 recommended points. We'll take this one because like I said, I tend to use the one with highest plate voltage, or the power consumption that's close to the maximum power consumption. So we're going to use this one, plate voltage 250. Again, the cassette bias, the grid bias is specified by the cassette bias resistor and the plate current. So we can calculate the equivalent grid bias by 68 multiplied by 10.6. Hold on. I got 68 multiplied by 10.6. Oh, okay. So this is not the one I used. Okay, so it's a 0.72. Okay, so I got it wrong. The current that flows through the cassette is the sum of the current through the plate and the sum of the current through the screen. So the total current should be 10.6 plus 4.3. So 68 multiplied by 15.9. Oh, sorry, 14.9. It's approximately 1 volt. So the grid voltage is the voltage across the grid and the cassette is minus 1 volt. And so we need to adjust. We need to subtract 250 by 1 to get the equivalent plate voltage on the tester. So it will be 249 on the plate minus 1 on the grid. HV2. Okay, so HV1 setting is like this, and for pentode we actually usually we are not interested in mu and RP. The reason is because the curves for pentode is actually very flat, which means the measurement error tend to be large, which means the very high plate resistance, because the slope is very low. So the inverse of the slope is the plate resistance is usually very high, and the measurement error will be amplified. So we even if we look at the data sheet, the plate resistance only give you a approximate value. Here it says approximately 1.0 megaohm, which is very big. So usually we are not interested in, for pentode we are only interested in the GM value, the current amplification factor. So we don't need to check the RP and mu, we only interested, but in GM. Okay. And for HV2 setting, where we know it's no longer linked to HV1, we need to configure the screen voltage here. It's 150 volt. It's enabled for negative V. Okay, so this part is ready. We can now move to the reference part. For the measured current. Okay. Okay. So let's finish this first. So the measure current, because we only display the plate current on the left hand side. So the display the current is reference current has to be the current on the plate. And from the data sheet, the current is 10.6. So if you want to check the plate current, check the reference current on the plate, you can specify the current here on the right section. in our case, it's 4.3. You can do that, but usually I skip this part. Okay, and RP is not important. You can put in 0 or anything you want because we are not going to calculate it. For GN, from the data sheet, the GN is transconductance is 5/200. So the setting for quick scan is done. Now we are ready to now we can move on corner. For corner test cases, I don't have a special setting for pentode. So actually we can use the settings for from chart. So if you have any idea how to like design more test cases for pentode connection, please let me know. So that's basically we complete the testing file configuration file for AU6 under pentode connection. So I need to mention one more thing about the child connected 6AU6. So here the setting, because the current through the tube is actually the sum of the plate current and the plus the screen current. So we need to specify HV1. The current on HV1 and the current on HV2, we need to sum them and display it on the y-axis. And if we do that, we need to change the current here as well. We need to sum the current. Okay. Quick scan. Yes, we need to sum the current here as well. So we need to come back to the 6AU6. Okay, it doesn't specify the screen current, so it's probably already summed. Okay, so if the data sheet has specified the screen current separately, you need to put that sum that into the reference column here. But since the data sheet combined the current already, so it's fine. It's so we only put the specified current here. The important thing is we want to display the sound current of both the plate current and the screen the current on the screen electrode. Save it. Okay, so that's it for 6AU6. Thanks again for watching my video. I see you next time. Bye bye.